Hello everyone, thank you for attending, and it's the last one, so it's almost over. I'm presenting today the project entitled Dynamic Reservoir Assessment to support CO2 sequestration in carbonate reservoirs. It's a project that is running under the umbrella of the EGP program, but we received funding from OERD with their new, relatively new CCUS program. So I must say today that I'm presenting progress on our 6 months period because we received the funding and we started the project in September last year. So keep in mind this is relatively preliminary result and relatively new work. So this is the abstract that you could find here and read later or at your convenience. And I will move to the list of project members. We are a team of 12 persons coming from the GSC in Quebec City and INRS, our academic partner at Quebec City as well. We cover a wide range of disciplines. We are 6 different disciplines. We are covering six different disciplines, and we are having 2 PhD students working on several aspects of the project. So the context of the work, so as I said, it's funded by OERD, and it takes the context is really trying to provide data and knowledge to prepare the Canadian CCUS picture, what we will be looking like in 2050. So hopefully we will provide new data. And as geologists and earth scientists, we focus on the geological storage question, of course, and we really consider the 3 components: the capacity of the reservoir, the integrity, and the injectivity. So that will be the 3 main components we will be working on, bringing, as I said, a new knowledge and particularly new know-how. The other point that is important for us was that we are in Eastern Canada. We are working in Eastern Canada, so we want to provide more data on different type of geological storage option within the Canadian sedimentary basin. And our real focus at the end will be really to bring more data on low porosity and low permeability carbonate. They are widespread, but at the moment maybe they are a little bit understudied. So the project is divided into 3 main objectives. Objectives 1 and 2, for them we use reference core material. So basically we bought rocks and they are relatively homogeneous rocks, and so they are used to develop lab scale methodology in order to better characterize how the rock will react and how we can store CO2 within them. So the objective 1 is doing the CO2 injection test in a reactor, and in this aspect, in this objective, we look at reactivity specifically. And the second objective is testing so the same type of CO2 injection scenario, but in another setup, and testing the application of geophysical tools to monitor how it's going on in the rock while we inject. There's a third objective. It's a bit more of an academic objective. I would say we choose a surface analog in Eastern Quebec. So there are carbonates that we know are carbonate reservoir at depths in Eastern Quebec. And we want to use those surface analog samples to develop new tools, or actually improve tools to reconstruct the porosity history of those reservoirs. So we'll be moving on the material now, a little bit more details on those reference rock samples that I talked about. So for objective 1 and 2, we bought a rock core from a provider in Texas. We selected 5 lithologies. They were selected because we think they cover a wide range of a wide and nice range of sedimentary rocks that occur in Canadian sedimentary basins. We have 3 limestone, 1 dolomite, and we also choose 1 sandstone, even though we are supposed to focus on carbonate. With the sandstone, we will eventually look at the carbonate cement in this sandstone and how it's reacting. I'm sorry. So as you can see, as you can see here, we have a wide range of porosity, and we have one example that is really low porosity and low permeability. For the surface analog, as I said, we choose a surface analog in Eastern Quebec. It's in Gaspésie. We have 2 quarry exposure, and they were selected because they are associated with one large emitter in Quebec. It's a cement plant called the Maquinis Cement Plant and Maquinis Quarry. So they are limestone and dolostone from the Silurian in Gaspésie. So next, I put together this slide to showcase the wide range of instruments and methods that we are using for the project in total. So with the three objectives, what we have to highlight here really is, what I wanted to highlight here is really the pluridisciplinary work that we are doing. We are also multi-scale. We are working at the lab scale sample, but with the micro city, we'll have image and data at the micro pore scale, the pore scale. But we go also up to several centimeters when we do other type of analysis. So it's multi-scale. And whenever we can, we do monitoring or measurements in situ, and we also try to do it real time. Sorry. So now I will try to cover the 3 objectives, one after the other, very quickly, a little bit more detail, and few words about what we've done for the 6 months period that we had. Sorry. This is the objective 1, CO2 injection tests using a carbonation reactor. So it's basically a pressurized vessel. We can control pressure and temperature, and we put the sample in a brine that is prepared to be in equilibrium with the sample we consider, and we do this experiment using CO2 in supercritical state. So this is the first scenario we've tried in red with the red arrow, where you can see we worked at 1,500 psi and 40 degrees Celsius. So the next slide shows the setup, or experimental setup, with our pump carrying the CO2 into our reactor. And we have the controller that ensure that we reach 40 degrees Celsius within the reactor. We made 2 test runs on an Indiana limestone at the moment. One of them lasted 3 days, and the second one was lasted a week. We have imaging before and after different states. So we have imaging of the sample in the dry state, then we put the sample in the brine, we did imaging, then we put the sample in the reactor, it reacts for a few days, as I said, and then we have imaging at the end, still in the brine, and at the end, after it was dry out. So we have a lot of data. It's under process, under analysis at the moment, but we already have images, and we could already see that we have, as expected, we have porosity evolution in the sample. Some places were closed up, and some of them open actually. So this is going to be more result for next year. For objective 2, that's the geological aspect of things. So we do the same type of experiment using the same condition, but we in a complete different setup. This time we are using an NMR core holder to put the sample inside with this brine. And but we are using the same pump. But the key important thing here is that the holder is X-ray transparent, so we could put it in the micro CT while we do the experiment itself. And the other key aspect is the geophysical monitoring, as I said. So the intent is to measure acoustic and resistivity data at the same time as we do the injection of CO2. So what we have done so far, it was a lot of work, much more than we anticipated, to put together the setup, the experimental setup. So the schematic is already one of our big results. It was not easy to find the most adequate instrument for the electric and acoustic tools to register the signals. This is not my work. This is Essen Vudovic PhD student work, but yeah. So we have a setup that is working. Finally, it was working well, measuring the properties, the geophysical properties when we were in a dry state, where the sample was in the colder and everything was mounted. But when once the injection occurred, there were leakage that were too important to keep the setup going. So it had to be stopped. And while considering the situation with the procurement issues and the supply chain issues as well worldwide, it was impossible to have the setup fixed by the end of the year. We know already what we want to do. We have a good plan for fixing up the leaks, but this is going to be done for the second year. And once it's working, and once we have our setup airtight for the injection, we will be using the same experiment condition that we used in the objective one. So we will be able to compare samples, the sample state at the end of the experiment, and we will be able to compare all the data. Objective 3 now, maybe a bit late, but I'm just gonna go through very quickly. So as I said, we have 2 quarry exposure in Eastern Quebec where we sampled the Paleozoic limestones. We had 20 samples collected for the project at the moment, and we focused on karst samples, especially in the new quarry, the one associated with the cement plant. It was a type of sample that was never present before in the area. It was really exposed by this new quarry. So we use those samples to document the different type of phase of calcite cementation that occur in these carbonates, these Silurian carbonates. At the moment, we have the conventional petrography done, the CL petrography as well, and micro XRF mapping. And it was done for both samples for both quarries. And based on those results, we made a selection of samples that was sent for further geochemical analysis in Ottawa with colleagues doing LA, ACPMS, and eventually uranium lead dating on calcite. So this is also in progress, and we will expect results actually pretty soon at the end of the month, so early June. So to wrap up the presentation, I put the next steps for every objective that we have. For the CO2 injection in the reactor, we will reproduce the injection scenarios on the other lithology. So we still have 4 lithology remaining to test. We already have the sample, and we also intend to try to mimic a deeper reservoir condition using a pressure of 2,500 psi and a temperature to 60 degrees. For the geophysical monitoring of CO2 injection, as I said, we need to upgrade the co-holder to make sure we work airtight. And then we will run the same experiments using the same condition, the experiment using the same condition from objective 1. And finally, for objective 3, well, we'll have to interpret all the petrographic and geochemical data that we gather on the surface analog from Geophysical. And we intend to combine them to produce a comprehensive porosity history of those carbonates. And if we have time, we will add additional surface analog from Eastern Quebec. We already have a few candidates in mind. So we'll have plenty of things to do for the second year of the project. So this is it. I have no idea if I'm too long, it was too long or no, but yeah. Thank you very much, and I will be happy to answer any questions.